Okay. So as I mentioned before, I went through all the gene lists. So we analyzed 7 different lung cancer data sets. They had lung stage in them, sometimes from 1A to 4. We ranked those. We correlated gene expression. So what we did was we found genes that either went up or down with the stage of the lung cancer. From those 7 different studies, we ended up with a list of the top 1,000 correlated genes. Okay? From your list, what I did is went through and found in those top thousands whether any of those genes were in at least another gene list. When I did that, I ended up with this list here, and we're going to import that, and you're going to see exactly what it's all about. Okay, so new, you're going to go to new, corr analysis. Everybody with me? Mm-hmm. It's still not uploading? Okay. Well, this is recorded, so you can watch once we get to this point. Okay, new corr analysis. I hit new corr analysis. Okay, brings up this window here, create corr analysis. I'm going to upload a new data set. So upload. I know you guys have all done this before. Let me see, where is mine? Yep, lung cancer studies. And so I called it...
Is it the folder or is it a specific document?
It's not the folder. You want the specific file. Actually, let me find that here. I think I put it. Oh, final lung cancer gene list. So it should say all lung cancer, adeno, SP corr, top 1,000, at least 2, and grab the text file. That Excel file I'm giving to you to play around with. Okay. Everybody see it? All lung cancer.
Is there multiple IDs?
Multiple IDs. Oh, you haven't done it yet. Oh, I mean you downloaded it. So wait a minute. So I'm going to hit this. Okay, double click everybody to this window here. Yes, no, maybe. No?
I forgot to extract. So I'm extracting right now.
Okay. Nothing ever goes as planned. Okay, so here's our IDs. I think the best thing that we can use... Oh, wait a minute. I gave you the whole thing, didn't I? Yeah, there's multiple IDs in there. So here's what we did is I grouped them based on the... What do you think this list contains? What do you think the identifier is? So I'm going to put ID. Gene symbol. And it should be up here. Actually, your software should recognize it. Usually it takes the first column. If we look here, it already did that. Gene symbol, human. Good software. I love it when it thinks ahead of me. Okay, everybody do that? So now we're going to go over to, see this sum column? It's after all these numbers here. Basically what I did was I turned the identifiers into ones, and I was going to make you do that, but due to time constraints, we'll do that maybe later. So here is, this column contains the amount of the number of studies this gene was in. So if we look at the top here, this gene NFIA was in 5 of your gene lists. That's pretty good. If we go with our old analogy, you know, this gene was hanging around 5 banks out of 7 that were robbed. Do you think it's guilty?
Yes.
Oh, heck yeah. Yeah, we don't even have to go to trial on this one. So we're going to go to observation 1, hit observation 1. Instead of putting full change, let's put other. Because this is the number of studies that it was in, and I want to see this information in the analyses. Okay, we're gonna go over here, and I also took the log rate, or I took the median. Right over here, and we're gonna make that observation 1 still. Now we're gonna just make that, it's gonna turn to a log ratio. Everybody got that? What is this value here? Does anybody remember?
Is it the p-value or the r?
Not p-value, r-value, yes, thank you. If it's negative, what does it do as the cancer gets worse? What, as far as the level? Yeah, it decreases, right? If it's got a positive value, it increases with as the lung cancer gets worse. The closer these values are to -1 and 1 respectively, the more correlated it is. The more certain we are that it's correlated to that particular variable that we're looking at. Okay, everybody do that? All right, plug and chug, save and create analysis.
You don't have p-values?
No, we don't need p-values. That's the thing is, where would we, which p-value would we use? Remember, this is a collection of all of those genes that were at least one in 2 of those lists. Some were in 5 of those lists.
I have a quick question.
Yes.
When we're analyzing this, you know, have different like a matrix, illumina. How do we account for
Because we went with gene symbol.
that? Gene assemblies?
Yeah. Here's what I did was I imported all of our gene lists into IPA. I did a comparison analysis, and I'll show you that in just a minute. And then from that comparison analysis, it grouped everything based on similar genes, and it didn't care whether it was Affymetrix or Illumina. From that list, then I turned the IDs into ones, and then I could add how many times that gene was in each list. Does everybody see how I did that? And that Excel file, you'll see exactly how I did that. I also did it with the upstream regulators, and that's going to be awesome. I was looking at it. It's like the rock stars. All the rock stars of lung cancer there. Okay. All lung cancer, adeno, SP corr, we can go top 1,000, at least 2. And I'm just, so I can separate this, I'm going to put my initials there. Okay, hit save. Okay, now it's creating the analysis. Okay, we can adjust the settings here. I'm going to leave everything just how it is, so everybody's looking at the same kind of list. So from this, if we look down here, we can see out of the 955 gene IDs that I put in, 939 of them, this software recognizes as these are genes that have like a criminal history, something that we can use to group them together. There's something there. A lot of these genes, there's replicates, and then there's some genes that just, they don't have any, characterized transcripts that, we don't really know what the protein does, so we can't really put them into this software. So here's the unmapped IDs, and you can see some of these here. Actually, some of these have more than one gene. That's why it doesn't recognize it. Okay, so we're here. We can also look to see what our range is. So we can actually say, hey, how many are upregulated? So remember, we have 955. I can go, I just want to look at the upregulated, and I can recalculate. So a little less than half, most of them, the majority of these genes that we're going to look at are increasing with cancer. About maybe, I don't know, what is that? 42, 43% are decreasing with cancer. So it is biased to genes that are actually increasing as the cancer gets worse, but we got to do what we got to do. So I'm going to hit both up and down regulated again, recalculate, make sure I'm getting the 939. I am. Now I'm going to go down here and hit run analysis. And then you can just save it as whatever you want. Okay. Everybody do that? Okay, it's going to take a while to crank through. again, what we did was we sent instructions. We basically sent this gene list to somewhere in California. Their supercomputers, which are tied to all this scientific information that we know, well, they're basically using that database and analyzing your data set with that. And then when it's finally done, it'll export that data onto this screen and you'll be able to see it. Okay. Let me stop there.